Alright, let's look at a couple of word problems. So here's the first one. We have an online shop, and let's say our online shop needs to send 72 shirts, 100 hats, and 144 bags to some supplier. Now for cost reasons, we want to send these in boxes as small as possible, but the key is that each box must have the exact same things in them. So we can't put like one shirt in a box and send it, because that'll be different than putting one hat in a box. So each box needs to have the exact same things in it. So we're asked to figure out, well, how many boxes do we need and what is in each box? Remember, each box has the exact same thing in it. So maybe pause the video now and see if you can figure this out. If you find it a little difficult, maybe change your numbers to something a little bit easier. Maybe make it 8 shirts and 10 hats and, I don't know, 6 bags or something like that. Whatever. Anyway, pause the video now and see if you can decide how to do this problem. I'll give you a hint. It will involve either a greatest common divisor or a least common multiple. Alright, so let's see what's going on here. So I'm going to draw a little bit of a diagram to help us before we write down how to solve this problem. But imagine these are our boxes. We don't know how many there are going to be, so I'll just put some dots here. But what we want to do is we want to take our 72 shirts and we want to divide them evenly into our boxes, and we want to do it with as few boxes as possible. Okay? But we also want to do it with our 100 hats. So we need to divide our 100 hats into these boxes as well. So it needs to be a divisor of 72 and 100. It needs to be a common divisor. So hopefully you can see what's going on here. And same with 144. So we need to divide 144 bags into our boxes as well. So we need a number of boxes that is a divisor of 72, 100, and 144. And we want the boxes to be as small as possible. We want to have the largest number of boxes where we can do this. So we want the greatest common divisor. So we are looking for the greatest common divisor of 72, 100, and 144. Now pause the video now. See if you can work that out. Look at the previous video if you're unsure. That goes over the steps to do that. So hopefully you've calculated that the greatest common divisor of these numbers is indeed 4. So we need 4 boxes. So that's part 1. And what's in each box? Well, each box contains, well, we have our 72 shirts. We're dividing them into 4 boxes. 72 divided by 4 is 18 shirts. Then we need 100 divided by 4, which is 25 hats. And 144 divided by 4 is 36 bags. So each of our 4 boxes is going to have 18 shirts, 25 hats, 36 bags. We can't have any more boxes than 4 because there is no way to divide up 72, 100, and 144 into smaller equal groups. So the smallest you could do is 18 shirts, 25 hats, 36 bags. Let's look at another word problem. All right. So let's say that we own a burger place. And we need, for our burgers, we need patties, buns, and cheese slices. Now, patties come in boxes of 36 from our supplier, buns come in bags of 50, and cheese slices come in packs of 60. Now, our burgers contain, of course, a patty, a bun, and a cheese slice. And we want to buy quantities of each so that there are no either patties, buns, or cheese slices left over. We couldn't buy one of each because if we bought one pack of patties, well, we'd have 14 buns left over if we bought one pack of buns. So, and let's say, of course, we want to buy as little as possible. But we don't want any leftovers. So, I think it's a good idea now to pause the video and see if you can solve this problem. Think about how this can relate to the idea of either greatest common divisor or least common multiple, and that should help you. Okay, now that we're back, let's have a look at what's going on here. So, what we need is a number of burgers where it's a multiple of 36, because we want to use all of our burgers. It's a multiple of 50, and it's a multiple of 60. So we want a common multiple of 36, 50, and 60 so that we use all of our patties, all of our buns, and all of our cheese slices. And of course we want to buy as little as possible, so we're looking for the least common multiple. So we need to find the least common multiple of 36, 50, and 60. So again, pause the video, see if you can work that out, and then when you're done, come back and we'll talk about how to answer the rest of the question. Okay, so hopefully you were able to work out that the least common multiple of these numbers is 900. So we need to be able to buy 900 burgers in total. So we can buy patties in boxes of 36, buns come in bags of 50, and cheese slices packs of 60. So how many boxes of patties do we need to buy? So patties, well, we need 900 burgers, and they come in boxes of 36. So we need 25 boxes of patties. And I don't need to do any long division here. Here's the way I was thinking of it. I was thinking of it from the prime factorization of the least common multiple and the associative principle. So here's 36. 2 squared times 3 squared. And what's left over is the multiple of 36. That's the least common multiple. So 25 36s are 900. So that's how I'm thinking of it rather than doing the long division. If you have the prime factorization of a number, well, division becomes pretty easy because you just group what you're dividing by, and what's left, that's going to be your quotient. So 900 divided by 36 is 25. Let's do the same thing with buns. So buns, again, we have 900 burgers, and it's in packs of 50. And where's 50 in here? I'm going to erase this and then draw it again just so I can regroup. And maybe I'll do it without the exponent. So it'll be 2 times 2 times 3 times 3 times 5 times 5. And we need 50. So 50 is 2 times 5 times 5. So I'm going to take this 2 and these two 5s. And what do I have left? I have 2 times 3 times 3. So that is 18. So 900 divided by 50 is 18. And cheese slices, well, 900 divided by 60. So what's the prime factorization of 60? Well, 60 is 2 times 2 times 3 times 5, which is, let me highlight those. I'll highlight those in green. 2 times 2 times 3 times 5. And what do we have left over? Well, we have this 3 times 5, which is 15. So 900 divided by 60 is 15. So we need to buy 25 boxes of patties, 18 bags of buns, and 15 packs of cheese, and then we can make 900 burgers with nothing left over. And that's the fewest number of burgers we can make with nothing left over. You can view greatest common divisor and least common multiple in terms of Venn diagrams as well, which is kind of helpful. So imagine that we had 180 and 144. Now, I worked out the prime factorization of these, and I put it next to it here. Now, we can think about these as being elements of like a set. It's not quite a set because we have repeat elements. We have 2 2s, 2 3s, and a 5. But you can think of it like a set where you're allowed multiple copies of the same element. And 144, we have 4 2s and 2 3s. So let's put in what we have into this Venn diagram. Well, what do we have in common here? Well, 180 has 2 2s and 144 has 4 2s. So we can put 2 of those 2s in the intersection, and then 144 has 2 extra 2s, so we can put them outside. So that deals with all of the 2s in the prime factorizations of both numbers. 180 has 2 factors of 2. 144 has 4. These 2 and these 2. The 3s, well, both of them have 2 3s, so we can put those in. There they are there. And then 180 has a 5, and 144 doesn't. So I can put the 5 over here, since it's a factor, a prime factor, of 180, but not 144. So looking at this, well, the prime factors that are in common are in the intersection here. So this intersection gives us our greatest common divisor. That's pretty cool. And, well, the least common multiple, that's going to be the union of these. This is our least common multiple. So we can view greatest common divisors and least common multiples in terms of Venn diagrams. So let's try with the numbers that we had in our previous video, since we already had the prime factorization of that. Let's do 42, 294, and 132. So 42 was 2 times 3 times 7. 294 was 2 times 3 times 7 squared. And 132 was 2 squared times 3 times 11. So we have three numbers. They aren't the best circles, but just bear with me. So this will be the circle for 42. This will be for 294, and this will be for 132. Now, what do these guys have in common? Well, they have 1, 2. Let's do the 2's first. Each of these has a 2 in common. But there's an extra 2 in 132 that's in not the other two numbers. So I'll put the other 2 in the circle for 132 and in the bit of the circle that isn't part of 42 or 294. So it's just in 132. Okay? All of these have a factor of 3, so I can put 3 in the intersection of all three numbers. Okay? 42 and 294 have one factor of 7, but 294 has an extra one. So I know that 42 and 294 share a factor of 7, but 294 has an additional one that the others don't. So that goes on the outside. And 132 has a factor of 11 that the others don't. So I'll put the 11 out here. Now you can see some cool things. Well, again, the greatest common divisor is the intersection of all three. So this is our, I'll do it in red since I did it in red last time. The intersection is our greatest common divisor. 2 times 3 is 6. And you can see, maybe I'll just point this out, you can see that if I multiply all of the prime numbers in each of these circles, I obtain the number that each circle represents. 2 times 3 times 7 is 42. That's all the numbers inside this circle. 2 times 3 times 7 times 7 are the prime factors of 294. If I multiply 2 times 3 times 7 times 7, I get 294. And 2 times 2 times 3 times 11 is 132. And of course, just like before, if I take the union of all of these guys, so this is the least common multiple. So that's pretty cool. But I can kind of just view two of these guys too. Maybe I want to look for the least common multiple of just 132 and 294. Well, that's going to be, I'm going to pretend that the circle for 42 isn't there. So it's going to be these guys, the union of those two circles. And it turns out that it's going to be the exact same as the least common multiple with 42, because there's nothing in that bit of the circle which doesn't contain 294 and 132. And the greatest common divisor, again, I can view this as the intersection of those two circles. So I'm going to do that in green, I guess. That's going to be this bit. So you can see, using Venn diagrams, you can get a lot of information of least common multiples and greatest common divisors if you think of them as unions and intersections.